So in this problem here, the key is recognizing, I think, as successive powers of z lie in the circle. And in a part, they actually make you do successive powers of w, and you see that when you put this to the power of 2, you get a 4, and then you get an 8, and then you get a 16. And you can see that they're getting bigger and bigger and bigger. Now, when I take w and I divide it by the complex number minus 2i, and I'm going to take that and raise it to 2, and then 3, and then 4, and so on, it always wants this number, whatever this number is to a power, to lie on a circle, which means these values here have to always be the same length. And so if I want to be the same length, this a value here, the a e to the minus pi by 4I, this a value divided by the a value of this, so this is the radius of the number, the length of the number, by the length of this number. In order, as I make the powers grow, they have to be the same so that the radius is 1. And so I'm going to have a e to the pi by 4i. 2i minus 1 is going to be 2 minus 1. Oh, sorry, 2 squared minus plus, oh my goodness, 1 squared, which is the square root of 5. So this number is 5e to some angle that I don't actually care about, right? So in order to z to some number here, to this power get bigger, that has to be equal to 1 so the radius doesn't change. And so that means that a value has to be square root 5. Hope that helps.